Hello, we're going to be looking at solving systems of linear equations. And so we know that linear equations give us graphs of straight lines. And overall then, because we have straight lines, we have three options. Either they don't cross at all, they cross at a single point, or we actually have two different looking situations, but it's only one line. And you can have equations that look different, but then when they get simplified, they're the same line. I mean, I don't look the same as when I get out of bed in the morning as I look when I get to work, but it's still me. So a solution for a system is a point or points that make the equations in the system true. Just like a solution for a single equation has to make that one equation true. If it's a solution for a system, it has to make them both true. So when you're looking at a graph, the solution is the point or points where the lines intersect, and if they don't intersect, there's no solution. Now, if there's no solution, often this is called inconsistent. Like they've given you a problem that you cannot solve, it's inconsistent, no solution. Those words go together, okay? When there is a solution, then you have a consistent system. They won't really talk about that one as much then, but consistent could still mean that there were two separate lines or there's just one line. And we also have additional words that go with that. If it's consistent but two lines, then we say consistent independent. Those lines are independent of each other. They just happen to cross paths. If they're the actual same line, then they are independent. Now, when we say that there are infinitely many solutions, you cannot just pick a number wildly and make it a solution. It has to be a point on the line, okay? So while we have infinitely many solutions, the solutions are every xy on the line. So you can't just wildly pick any number. You can pick an x and just plug it in and find out what the y is, or you could pick a y and plug it in and find out what the x is, but you can't pick them both at once. Okay, but we're not always going to be solving graphically. We do know that, again, a system has to make them both true. And so one of the first things we do is just get to check out and see, is it true? And this is similar to when we checked out to see, is it a solution for a single equation? What we want to do is we want to plug in our values and then plug in our values, same values in both of them, and you've got to see, does it make them both true? So the moment you start to plug in values, we're not sure it's really going to equal that. We just have to check it out. So as I do this, this becomes 2 minus 6, and 2 minus 6 is -4. That one checks out. This one becomes 2 plus 2. 2 plus 2 is 4. That one checks out. Since they both work, yes, it's a solution. All right, let's do one more of those. If I'm plugging in -4, 3, and -4, 3. All right, this one is -4 plus 6. -4 plus 6 does equal 2. This one ends up being -4 minus 6. But -4 minus 6 does not equal 10. I mean, does not equal 6. It equals -10. So this one is a no because it only worked for one of the equations. Some of your homework will just ask you, is this a solution? So that's what you do, is you replace the values and see, is yes or no, does it make them both true? Now, when you actually have to find the values on your own, we have three methods here. And over the next several slides, what I have is examples to show you graphing, and then substitution, and then elimination. And on some of those, we'll do the same example again, but by a different method so that you can see that they all work. Now, most of the time, we're going to say the best way is the way the instructions tell you to work. So there are some of the cases sometimes in math where there's more than one method, and you can get the same answer from another method, and that will very well be true on these. But generally speaking, they have given instructions in this section based upon the way the equations are going to work out the easiest. So I really recommend that while you could use substitution when they tell you to use elimination, it's going to be a cleaner and simpler problem for you to work if you just follow the instructions. Now, first of all, let's look at graphing. And it says here before I click to the next slide, graphing is good for estimation, but it's often imprecise because it's very difficult to tell where the lines cross if they don't cross at a grid point. Like if a line crossed exactly at this grid point, then I wouldn't have any problem counting over and seeing where it is. But if it crosses somewhere in the middle, then I'm left to guess, is that halfway up or just a third of the way up? And you have to kind of guess and check. So it's generally, you're not going to want to use graphing unless it's okay to round. Even when we use our graphing technology, sometimes when we get those long decimals, we're trying to figure out where to round. So use graphing when they tell you to and otherwise don't. But now to solve by graphing, we could rearrange these to get x and y intercepts. I mean, we could rearrange them to get y equals mx plus b, or we can just use our intercepts, and they're both appropriate methods. So if you want to rearrange the equation to get y equals mx plus b, you can. If you want to just use intercepts, you can, and I may do both of those on here for us. So if I'm going to use intercepts, what I'm going to do is let x equal 0, and then I'm going to let y equal 0, and just think about covering these up. So if I plug in a 0 for x, this term goes away, and then if I'm not looking at that and I'm just left to solve 2y equals -4, I can divide by 2 and get -2. Then I want to do the same thing, only I'm going to plug a 0 in for y. So this term goes away, and I'm left with -2x equals -4. Divide by -2, and I get a +2. So that means I'm graphing by those intercepts in. Now, one of the frustrating things as I do this online is that we all know I can pick those points like 0, -2, and I know that's the point, and I can go to 2, 0, but if I try to freehand a line there, it is not going to be straight. So really what I'm going to have to do for this to be online is I'm going to have to insert a shape, and we will choose a shape that is a double-arrowed straight line, and we're going to try to shoot it through both those points and then possibly make it longer. Okay, and I wish I had done it in red. There you go. So that one's in red. All right, then we'll go back and look at our second equation, and just because I'm wanting to show you how you can do it both ways, we're going to do this one by rearranging rather than by intercepts. So if I wanted to rearrange this one, I would take this x term over, and I would have 3y equals -3x minus 18, then divide by 3. So I get y equals -x, because that's like -1x. You can put the 1 if you want to. But you also have to divide it into here. So that's going to be, that 3 goes into both of them, so that's -6. So I ended up with x minus 6. So I need to put a line there. And what this tells me, if you choose to do it this way, is this is your y-intercept. So I'm going to go down 6, 2, 4, 6 on my y-axis. And then I need to use a slope of -1, which means I need to go down 1 and to the right 1. So see, I didn't do intercepts on both of those, but you could. You can do intercepts, or you can do the slope intercept. So again, we're going to need to go, and I need to insert a shape, and I need it to be a line. And then on that line, I need to try to hit that point and the next point. See, even doing this with such a straight line, you start thinking, well, should it go over here or should it go up there because my dots aren't perfect? Again, we don't want to use this method if estimating is not okay. Now, we can eventually get it, but it's just a little bit harder thing. So my solution then is where these intersect, which you can see is right there. And so what is that point? And best I can tell, it's -2. And then -1, 2, 3, 4. But if you want to know for a fact, does that work? Then we need to check it over here. So if I plug them in, if I plug in -2, that becomes 4. And if I plug in -4 here, that becomes -8. And 4 minus 8 is -4, so it worked in that one. Now I'm going to do the same thing down here, plug it in to make sure it works. That is -6, and then -4 times 3 would be -12, and -6 plus -12 is -18. So it does work. Okay, so we have solved by graphing. All right, we'll do one more of those. This one, again, these are not even arranged the same way. And typically, what I do is simply use whatever method they've given me. Y is equal to 2x. That just reminds me that it's 2x plus 0, so it's going to go through this point right here at the origin, and it's got a slope of 2 up 2 and over 1. So I tend to just use it in whatever method they give me. So now let me go and get a line, so we know I can't draw one straight enough. Over here in blank space, we're going to insert a shape, a line. All right, guys. So, and then of course I wanted it to be red, and I'm going to try to make it longer because I never know how long they need to be so that they're going to intersect. So my first one I usually do really long, and the next one I only do long enough to see it. When you guys are graphing online, of course, it makes it just go all the way across. So now if I'm going to do this one, I could just bring that over. That might be the easiest thing this time, and say y is equal to 4x, because when it comes over it becomes positive, minus 5. And so then when I go to graph that one, I can say, well, -5, 1, 2, 3, 4, 5. And then a slope of 4 would be up 1, 2, 3, 4, and to the right 1. All right, so I need to insert my line, and we need to not only hit this first point, go through that second point, but I've got to make this one longer so I can see where they cross. Now this is definitely one I don't like as well, because they're not crossing at a grid point. So you just kind of have to guess, and it looks to me like is right about halfway. So what we're going to do is say that we think the solution is 1, 2.5, kind of bigger decimal so you can see it, 2.5, and then how far up was it? 1, 2, 3, 4, 5. And again, I can plug it in to check to make sure I've done this right. 2 times 2.5 is 5. So it checks in this one. -4 times 2.5 is -10, and -10 plus 5 is -5. So it checks in that one. So that is the solution. But now graphing is just kind of a pain a lot of times. So even though there's a lot of words on this slide for steps, this is actually a method that a lot of students use and understand pretty well. And that is substitution. What you want to do is replace one value. You get one variable in one equation all by itself. That's actually already done over here. So let's just kind of work it out. I have y equals 2x. Now I want to take the resulting expression. In other words, when you get one variable by itself, what does it equal? And I want to put it into the other equation. So if y is equal with 2x, I am going to replace this y with that 2x. So then I have -4x plus 2x. So I didn't write the y down, I've just got 2x equals -5. Now I didn't need to put parentheses around it, but I did on purpose, because you have to make sure sometimes if you're not just putting in one term, if you're putting in several terms and there's a minus in front, It can change it. It never hurts to put it in, and it can make a big difference if you needed it and left it out. Okay, so now my like terms, -4, because it says solve that equation. So whatever you get when you plug it in, solve that equation for the remaining variable. So I need to solve what's left here for the remaining variables. So combining my like terms, I have -2x is equal to -5. And then I need to divide both sides by -2, and I get x is equal to -5 divided by -2. But you know what? That comes out to 2.5, because this is the same problem we just did on the other page, guys. Now that I've done this, I did step 3. I solved that equation. So you want to back substitute. You want to take that resulting answer into what you did at the end of step 1. So now I need to take, I'm going to change colors just so we can follow my lines. I want to take this answer, and I want to go back over here and say y is equal then to 2. If it was 2 times x, it's 2 times 2.5. So y is equal to 5. All right, so what is my answer? My answer is an ordered pair. You want to write your answer as an ordered pair xy, 2.5, 5. Now, you really, when you start doing this much math, you really want to check your work. It's so easy to make a mistake. However, we checked this answer on our previous slide because it was the same problem. So that's my answer right there. So I think we're going to do this again on the next one, and I'll just kind of walk us through it. So we're going to solve by substitution. Well, step 1 says to get one of the variables and one of the equations all by itself. You cannot pick the wrong one. You just have to choose. So I'm going to choose to get x by itself, and when I rearrange this, I get x is equal to, again, I'm getting it by itself, so that's going to come over, y minus 6. Then you want to take that result, whatever that equals, and you're going to plug it in to the other equation for that variable. So I'm going to take y minus 6 and put it in this other equation instead of the x. So then I have 3 y minus 6 plus 4y equals -39. Solve that equation for the variable that we have left. So you just got to be careful. We have 3y minus 18 plus 4y equals -39. I have like terms here to combine, so that is 7y minus 18 equals -39. I need to add the 18 to both sides. So then I have 7y equals -21. Divide both sides by 7, and I have y equals -3. Once you have your very first variable and you know what your first variable equals, you take that answer and go back to what you did for step 1. So x was equal to y minus 6, so x is equal to -3 minus 6. X is equal to -9. So now my final answer here is going to be an xy value. Even though I found y first, make sure you write the x first. So it's -9, comma, -3. I'm just kind of highlighting that because we know I can't draw a box. That is my answer. So that's substitution. So again, at the beginning, we said there were several methods. We had graphing. We've done that one. Substitution, we've done that one, and now we're going to look at elimination. And elimination is definitely my favorite because it's less writing. Okay, you just have to think a little bit more at the beginning. So what we're going to do is line up the variables. Those are lined up very well. And then before I get going, I work these really from left to right instead of top to bottom. It's just a different way of organizing it. So I'm going to copy that over. So I have x minus y equals -6, and then 3x plus 4y equals negative 39. Now, step 2, choose a variable. Okay, so you would just choose the variable. It doesn't matter. Sometimes you will find that one of them looks like it'll be easier than another one, because generally if they have fewer numbers in front or the signs are already opposites, that's a little bit easier, but it's not going to make a difference. And so then we multiply by whatever it takes to end up with opposite coefficients. So I can multiply this top equation by 4. And I just kind of put it in parentheses here, and I don't need to multiply the bottom equation by anything. Because if I multiply the top by 4, I'm going to end up with a negative 4 in front of that y, and that is the opposite of 4. So then we're just going to write our results down. So I have 4x, because even though I only worried about the y's becoming opposites, you have to multiply the entire equation. So 4x minus 4y equals negative 24. And on my other one, I didn't need to multiply it by anything, so I have 3x plus 4y equals negative 39. So I have done step 2 now. I multiplied and I made my coefficients opposites. Now add the equations. So when you add these equations, I have 7x, the y's went away, equals, and then this is negative 63. Negative 63, divide both sides by 7, x is negative 9. All right. Now the rest of it really is like the previous thing. Once you have that very first, you have to take it back and back substitute in, and you can put it in either one of these equations. So you're just going to put it in the equation where you think it looks the easiest to work. So I'm actually going to take it to that top equation because I've got fewer numbers to deal with, but I'm going to write it down here. So that means I ended up with negative 9 minus y equals negative 6. Negative y equals, I'm adding 9 to both sides, so negative 6 plus 9 is 3. Divide both sides by negative 1, and y equals negative 3. So then what is the answer? The answer is that xy point, negative 9, comma, negative 3. Is that the same problem we just worked? Negative 9, negative 3. Same answer. So you can see that much writing, this much writing. It's not really that much different. It just seems like a little bit less to me to get that very first variable, but this is still the answer. So that's elimination. So let's do another one with elimination. Okay, I particularly chose this one because it's got fractions, but first of all, don't necessarily worry about that. Notice how grand it is. These actually have opposite coefficients. So choosing this to solve this by elimination is perfect, because if I choose y, oh, no, I wanted to write on the screen. If I choose the y's to get rid of, I've already done step 1 and step 2, really, because they're already opposites. So I can just draw my line and add, and I will get 3/7 x, the y's cancel, equals 6. Now, I can now divide by 3/7, but to divide by a fraction is the same as multiplying by the reciprocal. So I'm going to multiply both sides by 7/3. These cancel in over here, and I just get x equals. And here, 6, you can multiply and then divide, or divide and then multiply. 6 divided by 3 is 2. 2 times 7 is 14. So even though it's a fraction, you can treat it like different numbers. So now I'm ready to back substitute. Now, 14 is going to be nice to plug back in because it's going to end up canceling with the 7. So I can take this value, and we got a lot of lines drawn today, and I can plug it back in here for x, and what I get is 1/7 times 14 plus 1/3 y equals 5. Well, 1/7 of 14 is 2, and that's 2 times 1, so it's still just 2, plus 1/3 y equals 5. Subtract 2 from both sides. 1/3 y equals 3. Multiply both sides by the reciprocal, but the reciprocal of 1/3 is 3, and I find that y is 9. So now my answer is the x first, no matter which one you found first, and then the y. So that's my answer there. Now, a lot of people, I'm just going to show you a different approach here. Well, before I do this one, let me just mention what we could have done on this one. If you get something with fractions and you don't have opposites and you really hate fractions, I can look at this and I can think, oh, the common denominator is 21. Multiply every single part, all 6 of those parts with the fractions and the part without. Multiply them all by 21. Your fractions will go away. Here we are on this slide. I can do the same kind of a thing here. I've got all these decimals. I really don't like to work with decimals. So what I'm going to do is I'm going to multiply all of this stuff by 10, because these are in the tenths place. And what that effectively is going to do is move all of my decimals over one spot to the right, and then I won't have to write down all the zeros or decimals. And it will become 2x minus 5y equals -7. 5x minus 2y equals -7. And then you pick a variable that you want to eliminate. It makes no difference. I'm going to eliminate my y's. So that's just out my i's, stay on the right line. So now I want to say, okay, well, what do I need to multiply by so that I get opposites in front of y? Well, 2 and 5 both go into 10, so I'm going to use 10 and -10 as my opposites. If I multiply this one by 2, then in the top there, I'm going to end up with -10. So I'll multiply the bottom one by -5, so that I'll end up with +10. So as I multiply all 3 parts by it, not just one part. So I end up with 4x minus 10y equals -14. And -25x plus 10y equals +35. I did get my opposites, so I draw my line. I'm going to add my equations. Those cancel. 4x and a -25 is -21x. -14 and a +35 is +21. Divide both sides by -21, and x equals -1. And again, just like our other times, you can take what x equals, take it back to either one of these equations, and plug that in for x. So that'll become 5 times -1 minus 2y equals -7. Then this is -5 minus 2y equals -7. Add 5 to both sides. -2y equals -2. Divide both sides by -2, and y equals +1. So then our answer, x value first, -1, comma, +1. And that's our answer. So again, you can sometimes help yourself a little bit when they ask you if there's going to be a solution or not a solution and you're looking at equations. If you just think about what we already know about slopes and y-intercepts, if there is no solution, the lines had to be parallel. So if the lines were parallel, the slopes were the same. But if it's the same line, the slope is also the same. However, the moment you get different slopes, you know you're going to have one solution. So different slopes tell me there's one solution. But now the same slope could either be parallel lines or the same line, so I could have no solution or infinitely many. However, if it's the same line, then it will also have the same y-intercept. And if it's a different line, it's going to cross that y-axis in a different place, so it would have a different y-intercept. Okay, so just keeping that in mind, sometimes if they ask you if there's going to be one solution or different solutions, you could just consider, can I get this in y equals mx plus b form? And then just make a comparison, and in doing that, you wouldn't necessarily have to work things all the way out. So that was just a homework tip. Now here is a homework problem that is different than both of those. So it asks you to write two equations for two lines through the point, such that neither line is vertical or horizontal. Now I added this, I didn't have this in my lesson earlier, and then I had several students asking me questions about how to do a homework problem like this. So this is directly for homework help. So what we know is that if it can't be vertical or horizontal, then you have to have a slope that's not zero. Vertical lines don't have a slope, and horizontal lines have a slope that is zero. So if it is not, neither line is vertical or horizontal, what that is telling me is that the slope is not zero, but it does exist. So what I am telling you then is, if you know that, pick a slope. I guess that should be pick an M. Pick a slope. Okay? It doesn't matter what you pick. You just, as long as you pick a number that's not zero. So why not let M equal 1? It's always fairly easy to do our math with the number 1. Now, they already gave me a point. If they gave you a point, then they gave you an X and they gave you a Y. So this should start to sound familiar. If we go to y equals mx plus b, then they gave me a y value. I got to pick the m value. They gave me an x value. 2 times 1 is 2. I can subtract 2 from both sides, and I get b is -5. Okay, so that means one of my equations, then I could easily write now, I can say, well, I can go back and I'm going to put in the m I picked, but y equals 1x minus 5. So see, that's my y equals mx plus b with my understood 1 and the b I just solved for. Then pick again, because you have to have two lines. It doesn't matter what you pick, as long as you don't pick 0, and you can't pick 1 again. So you can pick -1, or you could pick 2, or you can pick 115, but nobody wants to. So I'm going to pick 2. Then when I go to plug this in, their value, y equals my m times their x plus b. Okay, well, 2 times 2 is 4. Now subtract 4 from both sides, I get -7 equals b. So once again, now that I have b, I'm ready to write my answer. Y equals, now it's mx, I picked 2 for m this time, and then plus b. Those are my two lines that go through that point, which really means I've written a system of equations that is independent and consistent. Even back up to here, they needed to go through the point, but if they were going to go through one point, they had to have different slopes. Okay? That's what happened. And I can check to make sure this works, because when you plug this in, they should both work. So if I plug in 2, I should get -3. 2 minus 5 is -3. It works on this one. If I plug in 2 here, 2 times 2 is 4. 4 minus 7 is -3. It works on both of them. So that's just a homework help thing to remind you, and that finishes up this lesson. All right? Just get in touch with me if you have questions.